Today you will be looking at Learning Target 8A, dealing with geometric sequences. Take a minute and get your Cornell notes set up so that you have it titled and you're ready to add notes to your notebook. The first question we want to ask ourselves is, what is a geometric sequence? A geometric sequence is where, to move from one term to the next, you must either multiply or divide by a certain number. So here on the left, we have a geometric sequence that is multiplying by 3. Each time, we multiply the previous number by 3 to get to our next term. Here on the right, we have a geometric sequence where we are dividing by 2. 16 divided by 2 gives us 8. 8 divided by 2 gives us 4, so forth and so on. So our geometric sequence is one where you are either you're either multiplying or dividing by a particular number to get to your next term. What is the explicit rule of a geometric sequence? Now, you want to know that this is the explicit rule because there are two types of rules, and you will need to know the difference between them. The explicit rule is a sub n, so the nth term here, equals a sub 1, or our initial term, our beginning value, times r, which is our common ratio. Okay, and our common ratio really means the number that you multiply or divide by each time. Okay, raised to the n minus 1. Now, a couple other things to add, little notes. This initial term, remember, this is our starting value. Okay, and the nth term is what we would call a future value. And all of these will make more sense as we talk about them more in the video and as you get a chance to practice. So that is the explicit rule. Now what we want to look at is, what is the recursive rule, which simply means how do we get to the next term from the previous term. So again, we have the nth term, a sub n, equals a sub n minus 1, so just the previous term, the term before our nth term, okay, and times our common ratio, so r. You will want to make sure that you have both the explicit and recursive formulas written down and can easily access them, because it will be something you will need to have in order to be successful on all tests and quizzes dealing with geometric sequences. Now, let's take a look at one of the key ideas in geometric sequences. That is being able to identify what the common ratio is. So here we have 3 different sequences. First, I just want to explain how the term thing works. So in this case, your first number is always your first term. Second number would be your second term, third term, fourth term. So right here we would know that this is our fifth term. Okay? And in blue you could say first term, second term, third term, fourth term. And in green you could count the same way. So I just wanted to make sure that terminology of what a term means is clear for you. Now, when we're finding the common ratio, we're looking for what number are we either multiplying by or dividing by each time. Well, if I look at this sequence in red, I see that to go from 1 to 4, I have to multiply by 4. to go from 4 to 16, I have to multiply by 4. So I'm multiplying by 4 each time. So my common ratio R is 4. R is being multiplied by 4. Okay? Now, if I look at the term in blue, I see that it's getting smaller. And I can see that from here to here, from 270 to 90, I'm dividing by 3. And from 90 to 30, I'm dividing by 3. Same thing applies from 30 to 10. Now, when I want to write my common ratio and I know it's division, if I'm dividing by 3, it's always 1 over the number I'm dividing by. So in this case, it's 1 over 3. Okay? So it's 1/3 because we're dividing by 3. This is key to know. Anytime it's division, it's 1 over that number. So I'll make a little note to myself here. So anytime I am dividing, it is 1 over whatever the number I'm dividing by is equal to my R, or my common ratio. Now, this last term, if you look at it and you follow the pattern, it's easy to see that each time we are multiplying by 2. Times 2, times 2 moving forward. So our common ratio here on this last term, R would equal 2 as our common ratio. Now, once we know how to find the common ratio, the next thing that we need to be able to do is to find the nth term. Here's where you will potentially use your graphing calculator. So I want to find the 10th term for this first situation here on the left. So what I'm going to do is I'm going to write out a sub 10 equals 2 times 3, 2 being my initial value, 3 being what I'm multiplying by each time, to the n minus 1, so 10 minus 1 is 9. So I'm going to pull up my graphing calculator here, and I'm going to type in, once I get it on, I'm going to type in 2 times 3 raised to the, so caret key, which is right there, raised to the 9th. So 2 times 3 raised to the 9th equals 39,366. So when I write this, I write a sub 10 equals 39,366. Okay, so that is the 10th term in this particular geometric sequence. Now, in my second geometric sequence, I see that my common ratio is R. Therefore, I know that we are dividing each time. So again, when I write this out, and I want the third term, so I want a sub 3 equals 81 times 1/3, and I'm going to always put that in parentheses, raised to the n minus 1, so 3 minus 1 is 2. Okay, so I can do this one of two ways. I can either start to write out my sequence, so I can say, okay, 81 is the first term. Second term divided by 3 is 27. Third term divided by 3 is 9. So I believe that a sub 3 should be 9. But let's check on my calculator to find out. So here, I'm going to go ahead and type in 81 times 1/3 to the second power. So I type 81 times, I have to put that fraction in parentheses, so 1 over 3, close those parentheses, and raise it to the second power. If I hit enter, I get 9. So I can in fact see that a sub 3, or my third term, is equal to 9 in this case. Now, this last one, we have a sub n equals 1 times 6 to the n minus 1. Okay, so again, we want our 8th term in this case. So we want a sub 8 equals 1 times 6 to the n minus 1. So 8 minus 1 is 7. Okay, so I'm going to go ahead and pull this up. And I'm going to type this in as 1 times 6 raised to the 7th. So if I hit enter, I get 279,936. So I get my a sub 8, my 8th term, equals 279,936. Now, it's important that you understand how to type this into your calculator because, as you can see, with the exception of the middle term, the first and the third examples are quite large numbers, and they wouldn't be easy to just calculate in your head. You need to be able to use your graphing calculator. Now, the one thing I do want to point out to add to this is just that reminder that this, in each case, this first number here, which I'm going to put right here, that's my initial value. Okay, so that's 81 in this second case, 2 in this first case, and then this last number here, okay, or this second number, that is my R value. That's R. So here, 1/3 is R. Here, that 3 is our common ratio, R. Just so that you can see the structure of those equations. You have your initial value times R raised to the n minus 1. Now, if you have any questions over this, feel free to ask when we get to the point where you're having to write these yourself. Now, the last thing we're going to do is we're going to ask ourselves, how do we write the explicit rule for a geometric sequence? So again, all of my formats are going to be in this form. A sub n equals a sub 1, my initial value, times R to the n minus 1. So I have to do this for each of my particular geometric sequences here. So in red, I can easily see that my initial value is 2, and that each time I am multiplying by 5. So my R value is 5. So to write my rule, I'm going to write a sub n, because that part doesn't change, equals a sub 1, my first value, which is 2, times my R value, so 5, raised to the n minus 1. Okay, and I've written my rule. That's all I needed to do. Now, here in blue, I look and I see that if I write a sub n, I want my initial value, which is 400. And each time I am getting smaller, I am dividing by 2. Okay, so if we divide by 2, that means our R value is equal to 1/2. So we get times, I'm going to put this in parentheses, 1/2 raised to the n minus 1. Okay? Now, in this last example here in green, what I can see is that each time I am multiplying by 7. So when I write my explicit rule, it's a sub n equals my initial value, which is 3, times 7, because my common ratio, remember, is 7, raised to the n minus 1. So as you guys can see, each time the two things that aren't changing, you always have a sub n, you always have raised to the n minus 1. The only two things you're looking to plug in are your initial value and your common ratio. If you have any questions on this, please feel free to ask either myself, Mr. Braychek, or Miss Knutson. Have a great day, guys.